Okay, hey, good morning everybody, and I want to talk to you about how do you prove that you have parallel lines. And before I do this, I need everyone to open up your textbook to page 134 and 135 and write the three postulates and theorems into your vocabulary packet. So postulate 3.2, theorem, which is the converse of the corresponding angles postulate, theorem 3.5, which is the converse of the alternate interior angles theorem, and theorem 3.6, which is the converse of the same side interior angle theorem. I need you to write down all three of these first, and we're going to give you a few minutes to do this in order to continue on with the notes. So go ahead and pause this video and write down those three things, the postulate 3.2, theorem 3.5, and theorem 3.6, so that we can continue. Okay. Now I have to assume that you have done that you have written these postulates down. And let's use these postulates to demonstrate each of these examples. Okay, now don't forget, in order to prove you have parallel lines, you're going to use the converse of the theorems we learned. So the converse, remember, the converse switches the if and the then. So we're going to use the converse switches the if and then. So don't forget, we started off with P implies Q, and now it's Q implies P. So this is the reason why we have learned converses, and we have to use the converses to prove parallel lines. So use converses to prove parallel lines. This is very important. Okay. It says use the diagram above. Which lines, if any, must be parallel if angle 3 and angle 2 are supplementary? So which lines must be parallel if angle 3 and angle 2 are supplementary? So I'm going to find angle 3. I'm going to find angle 2. First of all, you have to identify what kind of angles these are. So angle 3 and angle 2 are on the same side of the transversal, and they are exterior angles. So angle 3 and angle 2 are same side exterior angles. So we're going to use a different theorem. Matter of fact, if you guys turn your page to page 136, you'll see the theorem we're going to use. It is theorem 3.8, and it's called the converse of the same side exterior angle theorem. So it says which lines, if any, must be parallel if these are supplementary. These are the parallel lines. Notice the transversal is the line that connects them. So this is the transversal. So the lines that must be parallel are these two lines. So I would have to say line EC must be parallel to line DK because of the converse of the same side exterior angle theorem. Okay. So many theorems we have to use. We're going to continue to use these to do example 2. I'm going to clear my ink and scroll this up. Whoops, sorry about that. Clear my ink and scroll this up. Find the value of x for which L is parallel to M. Don't forget, L has to be parallel to M. We're going to show these lines are parallel. First of all, I'm going to identify my angles that are given to me. I notice I have the letter Z, and the letter Z are alternate interior angles. And if alternate interior angles are congruent, then the lines are parallel. So we're going to use the converse of the alternate interior angle theorem. Converse of the alternate interior angle theorem says if these angles are congruent, then the lines must be parallel. So I need to show that these angles are congruent. Which value of x is going to make that true? When I set these equal to each other, we're going to discover that. So I'm going to set my equations equal to each other and solve. I'm going to subtract 3x. 14 equals 2x minus 66. Add 66. $80 is equal to 2x. Divide by 2. X must equal 40. And I'm done with this problem. Okay, let me clear this ink and show you the next example. A rectangular wooden frame has a diagonal metal brace. The angles indicated were measured to be equal. Which sides are parallel? And explain how you know. All right, again, let's mark these angles. I can clearly see this letter Z. The letter Z indicates I'm dealing with alternate interior angles. So in order to prove I have parallel lines, I'm going to use the converse of the alternate interior angles. Theorem. Okay, so this is my transversal. The line that connects them is the transversal. This is the transversal, which means this line as part of the Z and this line which is part of the Z, these must be the parallel lines. So line AB would have to be parallel to line CD as long as angle ABC is congruent to angle BCD. And I'm done. This is the explanation, and this is the answer as to which lines are parallel. All right, let's continue on. Let me clear my ink. Let's take a lesson quiz. This is very similar to what your homework is going to be like. It says use the diagram and the given information to determine which lines, if any, are parallel. So again, you're going to prove or tell which lines are parallel, which means you're going to be using converses. Justify your answer with a theorem or a postulate. Okay, angle 6 is congruent to angle 3. Angle 6, angle 3. These are corresponding angles. If corresponding angles are congruent, then the lines are parallel. So what lines would have to be parallel? M would have to be parallel to N. How do I know? Converse of corresponding angles. Okay, they tell you for the next one, angle 1 and angle 4 are supplementary. Let me find angle 1 and angle 4. I'm going to mark it. Angle 1, angle 4. I clearly get a U shape. When I get a U shape, I'm dealing with same side interiors. And so the transversal is line M. The two lines are B and A. So I would know that A would have to be parallel to B. How do I know? Converse of same side interior angle theorem would have to tell me that. Okay, last one. Angle 2 is congruent to angle 4. Angle 2 is congruent to angle 4. Okay, this is very different. Very, very different. And they want to know which lines, if any, are going to be parallel and how do we justify our answer. In order for these two angles to be congruent, in order for any lines to be parallel, what would have to happen is they would both have to be supplementary to either angle 3 or to angle 1. Because if same side interior angles are supplementary, then the lines are parallel, but that we have the congruent supplements theorem that says if these two angles are congruent, then they're going to be supplementary to this angle. So the converse of the congruent supplements theorem would have to tell you that these angles are going to be same side interior angles to A, B, M, and N. In order for this to happen, all the lines have to be parallel. So in order for 2 to be congruent to angle 4, I would need to have A parallel to B and M parallel to N. How do I know? It would have to be the converse of the congruent supplements theorem and the converse of the same side interior angle theorem. Okay. It says suppose that angle 1 is equal to 3x plus 10. Let me erase the picture so I can see where angle 1 is. Angle 1 is 3x plus 10. Let me mark angle 1. Angle 2 is 3x plus 14. And angle 6 is x plus 58. You mark angle 6 with a different color and match that up with angle 1 as well. Find the value of x for which A is parallel to B, and find the value of x for which M is parallel to N. Let's start with number 4. A is parallel to B. In order to get A parallel to B, I'm actually going to use this line and this line, angles 1 and 6. Angle 1 and 6 are alternate interior angles, so I'm going to use the converse of the alternate interior angle theorem. And so these angles would have to be congruent, angle 1 and 6. So 1 is 3x plus 10. And it would have to be equal to 6, which is x plus 58. So we're going to solve this. I'm going to subtract my x. 2x plus 10 would have to equal 58. Subtract 10. 2x would have to equal 48. And divide by 2 means x would have to equal 24. So x would have to equal 24 for this problem number 4. In order to do number 5, I'm looking at M parallel to N, this one and this one. These angles are same side interior. So we're going to use the converse of the same side interior angle theorem, which means these angles have to add up to equal 180. Angle 1 plus angle 2 have to equal 180. So this 3x plus 10, angle 1, plus this 3x plus 14, angle 2, would have to equal 180 degrees. Combine like terms, 6x plus 24 would have to equal 180. I'm going to subtract 24 from both sides. 6x equals, say, minus 24. 6, 7, take away 2 is 5, 1. Divide by 6. X would have to equal, 6 goes into 15. Twice, 12 with 3 left over, 36, 6. X would have to equal 26 for angle 5, or problem number 5. Okay, you guys, I hope this is enough information for you to do your homework, and you have a great day. Okay, bye.